All right, so today we're solving equations with variables on both sides. When you start solving your equations with variables on both sides, it doesn't matter what you're moving. The goal is to get the variables on one side, the variable terms, and the numerical terms on the other. We call the numerical terms constant terms. So our variable terms on one side. So I'm going to move all my x's to one side. I'm going to subtract 2x from both sides of the equation. Next, I'm going to add 17, divide both sides by 3, and now we're left with 7 equals x. Now, if I had, by some chance, decided to move the 5x, let's see what happens. Negative 3x plus 4, I'm going to subtract 4 from both sides. Inverse operations, divide both sides by 3, and x is equal to 7. Okay. So, basically what I'm trying to say is it doesn't matter what I move first. What do I usually do? I usually move my x term so that it stays, move the x term so that it stays positive. So that's why I chose to move the smaller x amount, negative 2x. As opposed to dealing with that negative 3x, having to divide by 3 on the right, the negative 3 on the right side. So go back to your rules, and I want you to add one more thing. Look at rule number 1. I want you to add to isolate the variable. We're adding to one side of the equation. Pause the recording and finish writing the notes. Now let's try our next problem. All right, so with this kind of problem, what would be the first step that we do? What do we have to do first, Daisy? We have to use the distributive property, distribute first on both sides. So why don't you walk me through it? What would it be?
Okay, so you would have 4x minus 8 minus 2x is equal to 5x minus 15.
4x, distributing the 4 to the x and the 4 to the negative 2. Bring that down. And then distributing the 5x and the 5 to the negative 3 and bringing that down. Okay, next step, what am I going to do on the left side? On the left side, Mike? Combine these two like terms, and so that becomes a 2x minus 8 equals 5x minus 15. Next step, go.
I would subtract the 2x from the left side.
Subtract 2x from
both sides.
Both sides, good. And we are left with negative 8 equals 3x minus 15. Next step, Julia.
You add 15 to both sides.
Mm-hmm.
And then you get 7 equals 3x.
Okay.
Divide both sides.
And x equals 7 over 3. And we stop there. Are there any questions? Brianna, how is it? Okay. All right, so you want to try another one?
Okay.
This one's for you, Julia. Pause the recording and try the next one on your own. What you did. Step 1.
First, I distribute 3 to x plus 2.
Okay, and that became?
3x plus 6.
Good.
Then I distributed the negative to negative 2x, and then negative plus negative equals positive, so
Negatives times negative is a positive.
so that would be plus 4. Then negative 4x minus negative 1.
Good, minus 1. Okay, and now what would I do on the left side?
On the left side, which you have to combine like terms,
Mm-hmm.
and then that would be x, negative x,
And this is?
and then you would 6 plus 4 is 10.
Okay, next.
I was having trouble with that.
Okay, so now we can move, let's move our x's. How can I move my x's so that they become positive? Would I move x or would I move negative 4x? So it's always the opposite. So what am I going to do? It's the opposite of negative 4x. And then what do I have here?
And then you would have plus 5x.
Plus 10
equals negative.
Next step.
And then we have to take away 5.
No, undo the addition and subtraction. So it's always easiest to undo the addition and subtraction first. So how am I going to get rid of the 10? Because that's plus 10. What's the opposite?
Minus 10.
Minus 10. 5x equals negative 11. Divide by 5. Divide by 5. And x equals negative 11 over 5. Okay?
I did something wrong with negative 1 minus 10.
Okay. So I owe $1, I owe $10. You might think you're multiplying, but we're really adding two negatives. Does that make sense? Okay, so let's try another one. Right? Okay, one more time you have to work on this. Now, my clue to you is inside out. We start with distributing on the inside and then distribute outside and then keep going. Okay, pause the recording and you guys try it. Okay, so what am I doing first? Let's go right back there. Is it Aton? Okay. Good. Equals 10. I need you louder and faster. No, not yet. Minus 4. What do you need to do inside here? Okay, I need to hear somebody I can hear. Somebody up front here. Go, Dion. Fionn.
Dion? Okay. 2m minus 14 minus 5m. And then close it.
Close it. Okay. Next step. Keep going.
Next, you do distributive again.
We're going to do it now, the distributive, the second time. We distributed inside, and now we're going to distribute the outside one, the negative 4, to inside the brackets. Okay?
So, minus negative 8m plus 50.
When you say minus negative 8, you can say minus 8m or negative 8m, but not both.
Okay.
Minus 8m.
Minus 8m plus 56 plus 20m.
Okay. Aton, do you see what you did? How did you get 12? Oh, 6 times 2, yeah, okay. So what you did, well, let's go back afterwards. Let's finish this up. So what would I do next?
Well, I also forgot to combine 2 and negative 5m before doing it, but you can do it anyways. Combine negative, combined all the terms, so you get 12m.
5m minus 30 equals 12m. And then let's
Plus
do
66.
these two plus 66. We could have combined the like terms. It still would work out to be the 12m plus 66. And then I've got plus 30, I guess. And then I've got 5m equals 12m. I didn't follow my own rule. Plus 96. Subtract 12m. Subtract 12m. This becomes positive 7m equals 96. Divide by 7, divide by 7.
Not positive. It's negative.
It's negative, sorry. Negative 7. There we go. 96 over 7, and I can make the whole thing negative. Okay, questions? All right, so some situations arise when we are solving equations. And here's what we find. So sometimes we're solving an equation. Subtract 2x, add 5, and I have one solution. But look what happens here. Okay, I'm going to distribute. Are you guys with me? Now what would I do? Maybe move the combined like terms. It's 3x. And then subtract 3x. And what happens? 8 equals 8. What happened? Infinite solutions. So in this case, when the numbers, we eliminate the variable and we get something like that, we would say x can be any real number or there are infinite solutions. Okay? Yes?
You have to go all the way to 8 equals 8. You thought that 3x plus 8 equals 8.
I think you should go all the way to 8 equals 8 because it's a line of proof. That's what math is. Then we have the situation when I distribute and I get something like this. Look, if 3x is equal to 3x and these two are exactly opposite, it's going to end up being no solution. When I subtract the 3x, we get 2 equals negative 2. So in this case, when you get a false statement, there would be no solution. Does that make sense? So those are 3 different scenarios that occur. Pause the recording if you want to take any notes. All right, here's an example. I distribute, I'm combining my like terms. I get down here, I have a false statement, so what do we say?
No solution.
No solution. You want to try the next one? Otherwise, pause the recording. I distribute. We get this, so what's my answer? Infinite solutions. Okay. Or x can be any number. Any real number. I'm going to go through this really quickly. Find a number that is 20 more than 4 times its opposite. What is our unknown? What are we calling x? X stands for what?
20 more than 4 times.
No, it stands for the number. What is the word in it? It's that's unidentified, that we don't know what it is. So find a number. Here it is. Number is 20 more than 4 times opposite. What's that going to look like? Elise.
X equals 20 plus, no.
Plus 20 because it says more than.
So 4 times negative x, or negative 4x.
Plus 20. Got it? And so we would get x equals negative 4x plus 20. Subtract the 20. No, don't subtract the 20. Add 4x. Add 4x. 5x equals 20. Divide by 5. Divide by 5. X equals 4. Are there any questions? Well, that was the lesson for the day.